All right. Before we get started, I just wanted to do a quick high-level summary of Cloudera. Cloudera is basically a pioneer in building a modern data platform, and we have been starting the Iceberg journey before anyone else, building and delivering Iceberg enterprise-grade data lakehouse for 4 years. We were the first one to deliver the open data lakehouse powered by Iceberg. And we have integrated Iceberg across all our compute engines. We have about 7 major compute engines in Cloudera Data Platform, starting from streaming, batch, ingestion, Kafka, NiFi, Flink, all the way to machine learning and GenAI. And now we are bringing in Trino as well to the platform. And we support Iceberg on all the major storage layers like HDFS, and we are actually significantly contributing and innovating in Ozone, Apache Ozone, which is another open source object store. And we also support Iceberg across all major object stores like Microsoft Azure, AWS, and GCP. Lastly, we also are the first one to design, deliver, and GA Iceberg replication support. We were the first one to deliver that support in the industry. Cloudera is a big pioneer, as I said, in open source projects. We have about 40 plus open source projects, and we have about 25 exabytes of data under our management. That's how the huge volume and scale that Cloudera Data Platform is basically managing and servicing and supporting our customers. 95 plus our stack has been transforming into a modern and next-gen architecture and technologies, including Apache Iceberg, Apache Ozone, which is a much more dense cloud object store for private cloud form factor. It really significantly addresses some of the pain points people have been going through with the HDFS, and namely name node and metadata and all the hotspots issues and performance issues and small files problems, right? And that's where Apache Ozone really shines. Now, as I said, we are bringing in Trino to the stack as well. And lastly, Gartner actually named as one of the Magic Quadrant leader in data science and machine learning. So before we go to the talk, let's talk about what the industry challenges are today. I mean, every enterprise, every businesses are struggling with this problem today, even today. This is a continuous, perpetual problem. Businesses have been trying to throw different solutions at this problem at different time, but they have not really solved it yet. And the problem is that the explosion of data with the big data, and the data comes in from point of sales or OLTP type systems, or generating from the edge nodes and ingested into more of a transactional systems, and then they go into a data warehouse system. They get curated and then structured to do OLAP type of queries, right? BI type, analytic type of queries. And then, but some of the data marts, the business units want a segmentation. They want to do marketing analysis. They want to do production and sales or customer sentiments analysis. Then they start spinning up more data marts. What really happens here is that data basically goes through different evolution, and different copies of data get created. In some cases, same copy of data exists in 10 different places in the organization. You will end up with a complex ETL pipeline, replication and duplication, and it just becomes a nightmare. And ultimately, the businesses basically say, we don't know what's happening, which ETL is connected to which one, which system is feeding into where. If I touch this system, I don't know what would break. And so nobody wants to break the things, they keep adding more to it, right? This is how things really get complex, and at the end of the day, it becomes really prohibitively expensive for businesses to manage, maintain, and operate this. This is where the TCO really goes skyrocketed, and their ROI goes down the drain, right? And this picture shows like one business unit. This is one business unit in any large enterprise organization. You just expand this to multiple business units, like a large Fortune 100, Fortune 500 customers. They will have different divisions, different business units. To add on top of this, to exacerbate this problem, each business unit comes up with their own tech stack. One may be using Snowflake, one may be using Amazon, one may be using Databricks or something else, Google, or whatever tech stack they have. The reasons could be varying. It could be because this team has the expertise and skills, they have SQL knowledge, they have this particular platform knowledge, so on and so forth. Or the software is built by a third-party vendor and we have no control over what is being built and we just deploy it. This problem gets worse and worse, and that's where the problem starts more. All the business enterprises really want to do is that they want to have single, simple architecture that can help reduce their overall TCO, increase their productivity, increase their return on investment. Their ultimate goal is to build a data lake or data lakehouse. But essentially, what they end up with is data puddles. And that's the term I've been using to describe this problem. Because they have different tech stack, each of them writing data in their own proprietary format. And they cannot really share and consume and access the data. In order to share and consume, they have to replicate. That's one solution. Copy the data over to the other platform, transform it, and then reload it, ingest it, so that platform B can consume it. Or you could do a federation, which is the age-old technology, like two and a half decades old technology, SQL federation. Push the query to the compute engine. And then the remote compute engine would basically process the data and return you the results back. So this really doesn't really even solve the problem. It adds more complexity, more cost to the business, because you have to maintain and manage all these different heterogeneous tech stacks and different formats altogether, right? So to solve this problem, people have been working around with different Band-Aid type solutions. The three I highlight here are common Band-Aid type solutions. And with the Iceberg, people try to solve the same problem. One, using an external table, where platform A can point to a table that is stored in the cloud object store bucket. And with Iceberg, you just only need a root pointer, and your engine now can directly read the root pointer and process it. That's one Band-Aid solution people have been doing. But the problem with that is that you are not getting real-time data access. Because some other compute engine that is authoring, managing, optimizing, modifying the data, it keeps creating newer snapshots. If you're familiar with Iceberg. Because you're pointing to a root pointer, this pointer is static and scaled from a platform B perspective, right? It doesn't get refreshed. So that's the refresh problem that you have to deal with. So that requires some manual intervention or some automation to deal with it. The second problem people wanted to solve is, like the other way people try to solve is that meta-store synchronization, or what people call catalog synchronization. You have two different platforms, and platform A and platform B, where platform A owns the data, that's where the data is authorized, modified, manipulated, and platform B wants to read it, you just synchronize the metadata. That's the second option. The third option, which is really an ugly approach and a real dirty Band-Aid solution, will lead to a lot of data inconsistency, correctness, data integrity problem is, people, they say, well, our Iceberg has this register table option. I'm going to register the same table in multiple meta stores or multiple catalogs. Now all of them pointing to the same root table, root pointer. But now you created a different problem, which is a split brain problem. Depending on how many meta stores you have everybody thinks they are the master. And if anybody modifies the table, drops expired snapshots, now you've got data loss problem or data correctness problem, right? All of these are the problem today people are dealing with. So ultimately, what really drives the business needs are the technical value proposition and the business value proposition. Now, from the technical perspective, they want to really simplify data architecture. A data architecture that enables and empowers businesses to do multifunction analytics on a single curated copy of the data. Talked about the copy of the data gets like proliferating multiple copies by duplicating, replicating, right? Complex ETL pipeline. They want to solve all of those. Nobody wants to deal with the spaghetti ETL pipelines to deal with, right? And then they want asset stability, scalability, and performance, supporting write, audit, publish model, right? Real-time data access, not like metastore synchronization or dealing with scaleless problems, those type of things. The last point is more important, and nobody has solved this problem, but this is what industry has been asking for, businesses have been asking for, and at Cloudera, we have been trying to build a solution for it, which is unified security and governance across the data estate. Your data could be anywhere in your data estate. It could be managed, it could be in external data lakes managed by different tech stacks, heterogeneous tech stacks. But they want a simple, centralized security and governance to govern all the data across the estate. As a single security blanket. Right? For the business side, they want to unlock the trust data, but in a trusted, secure fashion, right? Empower cross-data platform interplay, and share and consume the data, whether you are consuming the data within your business units or with your vendors or third party or other consumers that are willing to monetize, they are willing to pay for the data. Take an example of Nielsen. Nielsen surveys data about everybody and anything in the world, right? And a lot of the companies buys Nielsen data to do analytics, to do customer sentiment analysis, to make predictions on where they should invest and what kind of programs they should invest in and so on, right? And so an example would be, a classic example would be Walking Dead. And AMC channel buys Nielsen data to study how many people are viewing the data, what is the demography, and then based on the demography, they price ad slots. And if you're going to be putting your ad between the Walking Dead show, then your price is really premium. And before and after, you have certain price slots, right? These are the things that businesses really use the data for. And the best price performance, that's what business really wants to use to invest in solutions that they can lower their TCO and increase their ROI. Ultimately, they want lower time to value, lower time to market. So how does this really solve? So Iceberg really solves this problem. But the definition of open data lakehouse, according to Gartner, is that it's a single curated copy of the data that unifies all the capabilities of data warehouse and also the data lake, but aiming to support wide variety of applications on top of the same copy of data, right? Analytics, BI, ML, and engineering, data engineering. So enter Iceberg, and as you all know, 2018 it started back in Netflix. By the way, started by one of the ex-Cloudera who went from Cloudera went to Netflix, started the Apache Iceberg. Provides all the capabilities of atomicity, all the asset properties, time travel, the branching and tagging, and the write audit publish support, and the REST catalog. All of this combined together is how it's going to be solving some of those architectural challenges and challenges that businesses are going through today to simplify and reduce their overall TCO. Let's talk about Iceberg REST catalog. It's nothing but an engine-agnostic open standard interface that simplifies the integration of a client and a server that provides the data and access to a data. And it actually brings in a lot more capabilities to it, more than just a simple interface. That it enables fine-grained conflict resolution, multi-table commit, and it provides the direct data access. You no longer need metastore synchronization or all the other workaround that we talked about earlier, right? Thus, it basically reduces the time to value, time to market. It quickly get this up and running and be able to consume the data. So this basically shows a high-level diagram of what a REST catalog interaction with a data lake and a service that provides access to the data lake. On the left-hand side, you see a client that is integrated with an Iceberg library. Let's take an example of a Spark as a client, and Spark is integrated with the Iceberg library, and it has extensions with supporting the REST client as well. Through the REST standard interfaces, that you would basically talk to a REST catalog server, and REST catalog is basically nothing but a shim layer that sits in front of any metastore that is Iceberg compatible. There's no standard, there's no one defined catalog implementation. It can back any metastore that supports Iceberg table, right? So you would basically use REST as an API interface as a shim layer to your metastore, and then you would plug in with your own authentication and authorization. That authenticates the incoming request and say, yes, you are a valid request, and it will provide a token and credentials back. And then with the credentials, it will come back and try to access the data. It will go through the proper authorization flow, right? And this is a generic architectural, high-level architectural flow. And you could plug in your own favorite authentication tools in here, right? Ultimately, what you are really providing is to the client is that for Iceberg, the interaction is only with the Metastore to get the table root pointer. Once you have the table root pointer and the right credentials to the underlying data, the client now directly goes and consumes the data wherever the data is. The data could be in any storage layer. As you know, Iceberg is storage agnostic. It supports wide array of storage layers, right? Here I'm basically showing major cloud storage providers, Apache Ozone, and a private cloud. The private cloud could be Dell ECS. Dell is building their own private object store, right? Or MinIO, or Ceph, or NetApp, or whatever. So putting together with Iceberg and REST catalog, this is where the true power comes in, right? Now with the REST catalog, because it's an open standard interface API that is engine agnostic, that doesn't need to go through all these complications of, oh, I don't have the right client library version. The server is on a higher version than what I am. All of these challenges, people deal with it today. It eliminates all of those because it's using a simple REST architecture with a simple contract of use the standard APIs that you can talk to a REST-enabled catalog server. With that, you can bring in any tool of choice. This is where the power of where the enterprises want to use, right? I do not want to be locked into one particular tech stack or one particular tool, one particular engine. I can bring in any compute engine, any tool of my choice that is compatible with the REST APIs, now can interact with the data platform. And now that through that, you would basically provide true multifunction analytics to consume the data that is managed and maintained by the Open Data Lakehouse. On the left-hand side, you can see all of these streaming engine and batch processing and all the compute engines that can ingest data, right? On the right-hand side, you would see all of the tools and the consumption flow of it. What are the benefits really? Basically building a unified curated data lake that is shared by multiple line of businesses. Multiple business units do not need to have their own copy of data. They don't need to have their own proprietary data, creating all these silos and endless complications anymore. They all can share the same data in the single repository of the data. Governed and protected based on their LOBs or business units, governance and regulatory compliance policies on top of the data. You can create roles and groups and set policies accordingly to your business unit, to your personas, all on the same single copy of the data, because each role and each group can associate with its own policies to govern that, but still underlying using the single copy of the data. So eliminates data duplication, complex replication, ETL pipelines, and you have a common single central integrated security and governance and lineage on the data. It also provides the ability to have segmentation, which is what the ETL data marts were trying to achieve. They don't want to compete with other shared resources, and they don't want to be bothered with the scaling contingencies, those kind of things. You don't need to worry about it anymore. Just spin up your own virtual warehouse. Because we decoupled compute and storage, you could spin up as many virtual warehouses as you need for your data mart, all but sharing the same single copy of the data. All right, so that's about where the REST catalog and the Iceberg is. There are some of the roadmap and proposals that are already active, underway in the community to even build, enrich the REST catalog interfaces to add more security, data access, and governance to it. And then we are also proposing a new capability for Metastore Federation support. If you think about this REST catalog, this is tightly coupled to one Metastore. It doesn't have the ability to federate across multiple Metastores today. Each REST service only backs to one particular Metastore. But in a real world environment, the enterprises have multiple data lakes. The data lakes doesn't have to be all homogeneous. It could be heterogeneous data lakes. It could be on heterogeneous storage layers. And so you want to be able to provide a true data virtualization from a consumption perspective. The consumer doesn't need to know where the data is stored, which catalog is managing it, and how is this protected. All of those should be hidden and be a magic from the consumption perspective. I go to one single endpoint, and single endpoint shows me here are all the catalogs available to you. Here are all the tables available to you. And now you'll be able to join the tables across different external data lakes, different catalogs. That is what really we are actually proposing for in the community. And that's the last part as Metastore Federation. And that basically brings in all of these capabilities together to provide a true zero copy, zero ETL, cross data platform sharing and consumption. And you have all of this left-hand side, all of these consumers who could be different data platform, different tech stacks, the different tools they could be using. And on the right-hand side, you have your producers who are producing the data. They can set the policies, they can govern, they can manage and optimize the data all through the data sharing server, which is essentially the REST catalog server. And the REST catalog server basically with the capability of federation, it can truly abstract out and provide a virtualization from a consumer perspective. It doesn't need to worry about which REST endpoint should I connect to, which catalog should I connect to. All of those is hidden from the end user. This is where we are actually going towards building this, and we are also leading this effort in the community, trying to push for this. And ultimately, what customers also wanted, just take it to this next level is, regardless of where the form factor is, whether it is in public cloud or in a private cloud, in a data center, in a secured air-gapped environment, the customer don't need to worry about it. They want, again, be able to consume the data, providing that simple data virtualization and unlocking the data in a trusted fashion. So this diagram basically shows, again, different compute engines. Some data could be in the public cloud. This data could be in an open source Iceberg format or in their own proprietary format. As long as the compute engine is Iceberg compatible, can talk REST catalog, it can consume data from, in this example, we are showing Cloudera Data Platform. It can be any other platform that supports Iceberg-based open data lakehouse. This compute engine can consume the data from here, from the public cloud, or from the Ozone, which is the private cloud object store, pull the data back in, and then they can now do join, aggregation, grouping, any kind of analytics on top of that. Ozone in particular supports S3 API, it's S3 compatible. So you're basically going to be talking same S3 APIs as you're accessing from a cloud object store. You will be using the same interfaces to talk to Ozone private cloud, private object store, and combine the data. Thus, it basically reduces significantly the TCO. So this is one part of the customer success story that we did. It's basically showing the flow of the data pipeline, streaming, ingestion, ETL, and the customer was storing the data in their own proprietary format. They were paying for that storage as well because it was stored in an optimized proprietary format. And they were not able to share and consume across different data platforms and across different business units. And so we basically helped them to transform that data, consolidate that data into an Iceberg, and then move all of those processing into a better tools that gives the better price performance. For example, Spark and your NiFi and Flink can reduce the overall cost. And integrating that with the dbt workloads to do the modeling, those modeling were run on the proprietary third-party BI compute engine, which was quite expensive for them. Like stacks of joins that are like 30 stacks of joins and 5 different grouping aggregation OLAP operations on that particular compute engine was way too expensive for them. Now they use the dbt integrated with the Impala and Spark. They were able to bring down the cost. So they were able to cut down their cost by overall about 78% of TCO. Right? That's that example there. So this last diagram, the last slide, I just want to touch on it, and then we can talk after the talk as well if people are interested. This is the one I'm talking about, how we are going to be building a federation, Metastore federation capability and REST, thus providing a simple data virtualization, more like data concierge service. The external client, any client basically talks to that REST endpoint, and it would basically hide the details and complexities of where the data is actually stored, whether the data is stored managed by Cloudera Data Lake or it is managed and maintained by external data lake. All this providing single authentication and token and credential management. So you could basically combine a table T1 that is in Cloudera in this marketing domain With the table T2, there is a Snowflake data lake or AWS data lake with table T2 to process the data, do the join and aggregation and process. Then lastly, we are also looking at extending our authentication support to integrate with customers' IDP deployments they currently have. Example would be like OIDC or Okta or Microsoft AD, because they already have everything built into their own identity management that it's all their platforms are currently using as a single sign-on. This will further greatly simplify the implementation and use and the end user experience. I think that's my last slide, so I just want to quickly run through and give you a highlight here. If you have more questions, you can I'm open and free to chat after the session today. Thank you.
All right, thank you, Vince. Yeah, we're running a little bit late on time, so Vince will be here afterwards for any questions you might have.